AP Stats, this should be short and sweet. All I'm doing is going over the exit ticket and then one problem that we skipped in the packet. All right, so number one, mathematically speaking, casinos and life insurance policies make a profit because of the law of large numbers. All of these could seem correct, but this is the most correct answer because the casinos are set up in favor of the casinos, right? You might have some short-term winners because in the short-term probability is unpredictable, but in the long term the casino's always going to get their money. The life insurance companies are always going to get their money because they wouldn't be profitable businesses if they weren't set up that way. So the long-term probability is that they will make money, so the law of large numbers is how they do it. Number two, suppose you toss a fair coin 10 times and it comes up heads every time. Which of the following is a true statement? This is definitely not true because the odds never change. The odds are 50-50. It doesn't mean that the next toss is going to be tails. Law of large numbers talks about things that are, talks about sample sizes that are like thousands or hundreds of thousands, not the next toss. We can never predict the next toss or the next thing to happen to a person. All right, B, conditional probability. We haven't even talked about that yet. Coins definitely don't have memories, so I hope no one picks C. D, the law of large numbers tells how many tosses will be necessary before the percentage of heads and tails are again in balance. What are we talking about? Heads and tails again in balance. This is a non-answer. E is the most correct answer here. The probability is 0.5. The probability does not change each time. All right, number 3. A store owner reports that the probability that a customer who purchases a lawnmower will also purchase an extended warranty is 0.68. Which of the following is the best interpretation of this probability? Well, we can go ahead and eliminate two answers, D and E. We don't know what's going to happen with the next 25 customers. We can never say for sure this many out of this many people and have it come true. Short term is unpredictable. Unpredictable. Alright. So we're between A, B, and C. For all customers who purchase a lawnmower, 68% will also purchase an extended warranty. For all customers of the store, 68% will purchase a lawnmower. For all customers who purchase the extended warranty, 68% will use the warranty. So we really just need to look back to the context of the problem. And this is telling us people who purchase a lawnmower will also purchase an extended warranty. So my answer is A. This last problem on the exit ticket has to do with a relative frequency chart. Alright, so an online customer service department estimates that about 15% of callers will have to wait more than 8 minutes. Well, I hope I'm not in the 15%. I hope I'm in the complement of not having to wait more than 8 minutes. The department conducted a simulation of 1,000 trials to estimate the probability. So this is a probability simulation. Here's the breakout based on relative frequency. So these are the number of callers that had to wait. Let me add to this. That had to wait longer than 10 minutes. 8 minutes. I keep saying 10. 8 minutes. Based on the simulation, what is the probability that at most 2 of the next 10 callers will have to wait more than 10 minutes? So these are those number of callers, and if we said at most, that would be 2, 1, or 0. That's at most 2. It can't be more than 2, right? So all I need to do is add up the probabilities for 0, 1, and 2. So I'm going to do 0.181 plus 0.345 plus 0.284. And that's going to leave me with 0.81, which is answer choice E. Alright, so that was it for the exit ticket. I think we skipped one problem in the packet that I wanted to spend some time going over. So remember the main things that we talked about in the packet, if I want to just quickly summarize. We talked about probability models, right? Your sample space with your different outcomes. We talked about the complement rule. We talked about addition rule for mutually exclusive events. And then we talked about the general addition rule. Alright, so looking at this. Use the two-way frequency table below to answer the following questions. Alright, A. Is sunrise or no sunrise mutually exclusive? So I've got sunrise or no sunrise. Can I have something that's sunrise and no sunrise at the exact same time? Remember, mutually exclusive is either or. Can be one or the other, but not both. Mutually exclusive is either or, one or the other, but not both. Is sunrise and no sunrise mutually exclusive? Yes, it is, because you cannot have both of these happen at the same time. So yes, it is mutually exclusive. Alright, is a view of the sunset or no sunrise mutually exclusive? Meaning, can I have, I'm going to use a highlighter this time. Can I have sunset happening while no sunrise? So do I have an intersection point between the two? Can I have both at the same time? Yes, 12 people have a view of the sunset and no view of the sunrise. So this is not mutually exclusive because it can happen at the same time. Alright, we're going to calculate the probability of having a view of the sunrise. And we're going to call that event R for rise, sunrise. Or, remember, or I want you to think union add, or union add. A view with no sunrise at home. So we'll call this event N. Alright, so we want the probability of R union N. Run, haha. Make that a bigger U for union. Alright, so we know that's P of R plus, because of our add, right, or union add, P of R plus P of N, minus what we double counted, which is the intersection. This is our double counting, right? Alright, so the probability of a view of sunrise is going to be 21 out of 38. Plus the probability of no sunrise is 17 out of 38. Now, was there any one I double counted just by looking at these two columns? Was there any intersection between these two columns of people? No. So there's nothing to double count, which means these are mutually exclusive events. I can't have them at the same time, so I haven't double counted anything. The probability of R intersection N is 0. There's no probability of it ever happening at the same time together. Alright, so let's go ahead and wrap up this calculation of R union N. So I'm going to do 21 divided by 38 plus 17 divided by 38. And that gives me 1 exactly, which makes sense because there's 38 people total in my survey. 21 of them have a view of the sunrise, 17 of them don't. Together they make up our whole sample space. Alright, while you're here and stuck listening to me, we're going to try something else. We're going to keep event R as view of the sunrise, and then we're going to add event S, which is a view of the sunset. Alright? So now I want you to find the probability of R union S. So go ahead and take a minute to find that probability. Alright, you could have set it up with our general addition formula. P of R, union, which means or add. So P of R plus P of S minus our double counting, right, which is P of R intersection S. So let's go ahead and calculate P of R, which we already did up here. 21 over 38. What about P of S? What's our probability of having a view of the sunset? Sunset would be 26 over 38. And we need to subtract out what we double counted, right? There's some people who have a view of the sunset and a view of the sunrise. Those lucky people are probably paying a ton for their apartments. So if they have a view of the sunset and the sunrise, we double counted them in both groups. So that's what this intersection means. It means sunrise and sunset. So how many people out of 38 have a view of the sunrise and the sunset? Hope you said 14 out of 38. This is my intersection, sunset, sunrise. Alright, so let's go ahead and calculate our probability now that we've gotten everything. Alright, so pretty soon you'll be seeing my new iPhone 12 on here, but for now you have to deal with this broken screen. Alright, so when I round up to 2 decimal places, I'm going to get 0.87. Alright, so that's the probability of seeing either a sunrise or a sunset. That word or. Union or add. Alright, hopefully that was helpful, and we will go over the next exit ticket on the next ed puzzle.